Welcome. So we've been looking around the edges of this problem, which is how do we work out and how do we visualize somehow the relationship between two or more variables. And we've been particularly looking at the difference between a frequency count of letters in a language and a frequency count of letters in a particular text to see if we can classify that text as a particular language, either in English or French or Spanish or Dutch or other languages. So what we're going to look to in this episode, we're going to look just at a slightly more statistical and mathematical way of doing this, which is using correlation, and then we'll just quickly touch on regression and regression models at the end of this. So if you look at the correlation between two variables, so this is usually plotted like this. We've got frequency of letter along the horizontal axis and along the vertical axis. We're no longer plotting the alphabet, we're plotting frequency in both directions. And here we're just plotting the English language against itself, so that there should be a perfect correlation because all of the letters will appear in the same frequency in each of the two axes. And because of that perfect correlation, we'll get a straight line. And as you see here, the points are all plotted on a straight line. I've only labelled a few of them because all of the labels would overlap and be a bit confusing. So this then gives a perfect 45-degree line in an equal aspect ratio plot. And suggests a perfect correlation, as we should get between the English languages and itself. Let's see this in action. So I'm just going to pull in a few more libraries, some statistical libraries, as well as the visualization libraries. So I've just read in the data that we need for these plots. So I've read in the frequency table, letter frequency raw, which is the frequencies of each letter in about 15 European languages. We've selected English with a variable called language. We've pulled that data out, and we've also read in the ransom text and the frequency used of the letters in the ransom text. So we've got our raw data to work with now. And the first thing we'll do is just plot the English language against itself. And there you go, the 45-degree line. It isn't the ransom text, it's English versus English, this one. And we'll switch it back so that we plot the ransom text against the English language. And you'll see the difference when something's not perfectly correlated. So here we go. This is the ransom text on the vertical axis plotted against the English language. And because the frequency of each letter is not quite the same, there's some variation from that ideal correlation line, the straight line in the middle. So now, it would be nice, wouldn't it, if there was a mathematical calculation that told us about the correlation and its strength, how good the correlation is. And in fact, there is. Pearson's correlation coefficient, usually called R, is one of those. And it ranges from -1 to +1. If it's -1 or +1, it's got a very strong correlation. If it's closer to 0, then it's got a weaker correlation. And we're going to calculate R simply using this pandas function here. We call correlation on one table with another table, and they've got to have matching numbers of rows and a list, in this case, of the frequency values for each letter. And then we plot it. And the graph that comes out is here. It's the same graph as above, but now we've got the R value to go with it. And an R value of 0.98 is almost 1. It's a very strong correlation that tells us that the ransom text is quite likely to be written in English. And we know from earlier analysis software that that's the case. Now we can increase the utility of this by looking at a bigger scale of data. So here we're going to do something called a correlation heat map, which Seaborn provides. You can do this in Matplotlib, it's just easier to demonstrate here in Seaborn. And that will plot a correlation, an R value, for every combination of languages in the raw data set. So for all 15 languages, it will cross-correlate them all and give us the R value. And I'll show you how it does that. So here's the cross-correlation table. I will go back to the slide so that you can see a bit more of the detail. So here's that in the slides. It's a correlation R across with every language with every other language. It will show you, for example, that if we look for Polish here, one of the worst correlated languages is with Danish. And in fact, that's the lowest correlation of all the languages on this plot, 0.55, an R value of 0.55. Whereas right next to it, Dutch and Danish have an R value of 0.95, which is the highest correlation value on the plot. The important thing to notice about this is that it's symmetrical, so the bottom triangle and the top triangle are identical. This means you only need to look at half of this plot, and in theory you only need to plot half of it as well to see this correlation here. If we add in ransom as a data source, we can get the correlation here of the random text with every single language in the dataset. You'll notice it's replicated across this horizontal line too. Not surprisingly, English turns out to be the highest correlated with the random text, but it's not very far off with, for example, Dutch 0.87, German 0.85 and French 0.85. So English is almost certainly the right answer, but there's this range in there as well. If you remember back to the software we used, it ranked Turkish as the lowest of the possible matches with this text, but here we're ranking it in this software with this correlation as Polish, but that's because a lot of the letters used to distinguish the languages were removed when we decided to just use the first 26 characters of the English alphabet to calculate these correlations with. What I'm going to go on to next, and I'll show you the code for this in a second, is regression models. So correlation is a single number which tells you the strength of the link between two variables. It doesn't tell you that there's a causal link. English didn't cause the random text to be written, but it does show you that there's a good correlation, and that might imply that it's written in English. And if it's the highest one, it's probably a good chance it is. A regression model is something different. It's a predictive model. The regression model here is giving us a linear regression, so it's a straight line which is in some way the best fit to the data. So given any value along the x-axis, it will give you a point value estimate for the y-axis. And you'll see there that what it's doing is it's creating a line that minimizes the error between the data and the line itself over all the data points. If we calculate the same for Polish, where we had the least correlation with the text, the random text, you'll see that the regression line is not at 45 degrees, it's slightly off. So it's not necessarily an impossible fit, but it's not the best fit in this data set. And you'll see if you use one of the translations of R values to meaningful labels, 0.6 is a strong correlation with something, whereas 0.8 is very strong and 1 is very strong. So it's not impossible this was in the Polish language, it's just the best correlation is with the English language. When you're using these technologies, watch out, R can be misleading. It summarizes the data as a single number, and that can hide lots of patterns. If you have some time, I would suggest go and look at Anscombe's quartet, because that's a set of plots with very different shapes that all produce the same R number. Now, let's look at the code for this. So, regression, which is often confused with correlation, is not correlation. Regression builds a model which can be used to plot a line through the data, which is somehow the best fit line. Best fit in this sense means it has the least error between all the points in the line. And we can do this quite simply in Python using a number of calls, but one of the simplest ones is to call to NumPy to polyfit, asking it for a linear line, a linear fit, and or to the SciPy stats package where you can directly call linear regression. In either case, what we're looking for is the gradient and intercept of that regression line. Once we have the gradient and intercept, we can use matplotlib's plot function to plot the x value with the y value, which is a gradient times the x value plus the intercept, and that will give us that predicted regression line. We also are going to plot a second line behind the scenes that you've seen, which is the ideal 45-degree line for comparison. Okay, let's run that. And here we've got the correlation plot. So we have got the correlation plot with R value, Pearson's correlation coefficient of 0.98. We've got the data points on there, and we've also got the regression line through them. And you'll see in this case the regression line almost perfectly fits the ideal 45-degree line. And that shows you a good fit. Let's just switch languages. Go Polish, which was the worst fit in this data set. So if we choose Polish as a language, this is the result. We get a regression line which is further from the ideal 45-degree line and the R value of 0.6, which we calculated already. And you can see the points are distributed quite a long way from the regression line. And the more distributed they get, the flatter this line gets, the less the correlation will be, and the less likely you are to be able to say that these two variables are related by correlation, or that you can plot a regression line. There are more things about regression lines that are worth looking at. So the R-squared value, which is a different measure, tells you the quality of the fit of the regression line to data, which is different from the coefficient of correlation. But we won't go into those here. We'll just show you the basics. Okay, thank you for watching this episode, and we'll be back somewhere soon.